Welcome to this series of introductory lessons related to the time value of money. My name is Brent Pritchard. I teach college finance courses, and I'm here to help you grasp this all-important concept. This introductory series is designed to help you learn how to apply the mathematics of finance in less than a month, provided you commit to one or more lessons a day. It's that easy. Acquiring the hard skill that is the mathematics of finance does not need to be hard. I hope you enjoy this fun new take on this age-old concept. And after you've done that, please consider telling your friends about this channel, TVM Rules, and the book, Would Your Boomerang Return, also known as the Boomerang Book, that made it possible. I like to start every class with a quote, so here we go with the quote of the lesson. I'm not sure who came up with this saying. I heard it a lot growing up, and it stuck because it made the book. If it quacks like a duck, it's a duck. The focus of this lesson is on a certain type of payment, a hypothetical lump sum payment, a PMT payment or annuity for which a present value or future value has been determined using the PV key or FV key on your financial calculator. Remember, the PV and FV keys on your financial calculator are reserved for single or lump sum payments. The PMT key is used for an even annuity and an even perpetuity, or a perpetuity that is uneven but growing at a constant rate. When I hear the word even, I think equal or level, which is why I think it helps to classify a perpetuity with a PMT payment that is growing at a constant rate as uneven. Just helps to keep things straight. So you can use the 5 primary TVM keys on your financial calculator to solve for all but the uneven annuity or uneven perpetuity that doesn't consider a constant growth rate with respect to the PMT payment. And this sums it up because we've not only talked about the 2 different payment types or classifications, but also the 4 different subclassifications. Frequency, or the F of the acronym FAT, tells you whether you are dealing with a lump sum payment or an annuity. A and T, which stand for amount and timing, tell you whether you're dealing with an even or uneven annuity or perpetuity. So here's the real world situation for this lesson. Let's get into this. You've got a friend who plans to go to college, and college is going to start a year from now. And this friend of yours wants to fully fund their college education, which is smart. And that's what we are going to figure out with our TVM wallet. Remember, the TVM wallet is the solution to analysis paralysis. It helps us with the 3 simple steps, and each window of the TVM wallet relates to a certain TVM rule, and we know that the mnemonic or audible aid indifferent guides us through the TVM wallet. It also helps us remember the TVM rules. So in the first, I stacked TVM wallets here, 2 of them. And in the first TVM wallet, I'm going to write in the 5 primary TVM variables or inputs, the keys on your financial calculator that you're going to be using more often than not. And in the first window of the TVM wallet, we are going to visualize what we have going on here. So let's just draw a complete timeline. 1, 2, 3, 4, 5. I'll put the time period markers on top of the timeline. And it just so happens that time period 0 is now or today, and your friend plans to go to college in 1 year. $30,000. This is a negative sign, negative $30,000. And so that's what it looks like. I could even clean it up since there are so many zeros there, and say negative 30K, negative 30K, Yeah, this looks a little bit better, doesn't it? Negative 30K, because the negative sign matters. Remember, the different payment types and signs matter. We were provided with a true annual investment yield of 4.5%. So we need to figure out, how are we telling time? What's the time span in between period markers on this timeline? We've already counted money. In other words, we've already determined that this is essentially an annuity, an even annuity, with a PMT payment in the amount of $30,000. So we've counted the money. Now on to telling time in this 312 warm-up routine. And the numbers in the 312 warm-up routine not only relate to the TVM rules, but also the windows of the TVM wallet. So we've counted the money, we've told time because this is an annual time span, and now we can read and write I, the true investment yield. We know that only a true annual investment yield will work, and that's great because we were provided with a true annual investment yield of 4.5%. So now let's get about circling what we're ultimately solving for here. The present value of an ordinary annuity is the first number that we are going to calculate. So we're going to put a rectangle around that. That's the intermediate step, because we ultimately want to determine the present value of an annuity due. We're going to circle that. And as we'll see in the second TVM wallet, we'll be using the FV key, or the future value key, to solve for the present value of an annuity due. So we have $30,000. It's negative $30,000. How many of those payments? 4. 0 for future value. And let's put an OA here to remind us that we're calculating the present value of an ordinary annuity. And when we run the math, and remember the TVM wallet is meant to be used in conjunction with your financial calculator. So whether you're at home or on the road, wherever you find yourself, if you're following along, hopefully you're plugging numbers into your financial calculator. And when we solve for this amount, we get $107,625.77. So that's the first completed TVM wallet. Now let's move on to the second TVM wallet, because we've solved for the amount in the rectangle already, the present value of an ordinary annuity. Remember, it's ordinary for the present value to be as of one period before the first payment in the series, and we're concerned with the value when college starts. So we'll go down to the first window of this second TVM wallet. We got a little more space, so we'll use it. And we've got $107,625.77, and we want to determine the value here, which is ultimately it really is the present value of an annuity due. We'll be using the FV key to calculate that. And this is why it helps to understand the building block time value of money equations, because this is the equation, the building block present value of an annuity due equation, that is going to be used here to support the math. So we haven't changed how we're telling time. We haven't changed the true investment yield. There's no longer a PMT payment. Why? Because we've used discounting to value this annuity stream, and in the process determined or calculated a hypothetical lump sum payment. So we can still use the PV register here. It's still a lump sum payment. It's just a hypothetical lump sum payment. So we transfer the value from the first TVM wallet down to the second TVM wallet. And this is a good time to mention that this is what I call the two-step operation because of this intermediate operation. Notice how the sign with respect to the $107,625.77, the sign has not changed. So we're not using a different sign. Also, we're using the same register. So we're using the PV key. We're plugging that value in using the same key. In fact, we can just keep it in the calculator, keep it in that PV register. We put a 0 for PMT payment to kind of reset what we've done already. So we don't want any stragglers. We don't want that negative $30,000 payment to come PMT payment to come into this second TVM wallet. So we got to make sure that we put a 0 for the value for PMT payment. Same thing for uppercase N. We don't want that 4 to come over, so we want to put a 1 in for uppercase N this time. And again, we're using the FV key to solve for the present value of an annuity due. And when we solve for the present value of an annuity due, we get negative $112,468.93. So there we go. Well done, we did it. Now let's double check our work like we do, and we're going to be using the building block present value of an annuity due equation. And here's the equation. Here's the add-on expression, 1 plus I, the true investment yield, in parentheses, 1 plus I raised to uppercase N minus 1, and then here in the denominator, 1 plus I raised to the power of uppercase N times I. So we've got a 1, a minus 1 in the numerator. We have an I, a true investment yield, in the denominator inside the square brackets. So let's work this out. And our even payment was $30,000. 1.045. How many of those payments? 4. So uppercase N takes the value of 4 minus 1. 1.045, again raised to the power of 4, times 0.045. And then here we have the add-on expression, 1.045. And when we work this out, we get $112,468.93. So I'm going to circle that number. That's the correct number. Now let's move on to the next situation. Storyline's pretty much the same, but this person wants to pay their parents back for the money that was fronted. So in this situation, we're going to be using the building block future value of an annuity due equation. But first, we're going to draw the TVM wallet because this helps us visualize what we've got going on. Not only that, but we are provided with the 3 simple steps to analyze and evaluate real-world time value of money situations. So let's start with the first wallet. I'm going to write in the 5 primary TVM variables that you see in the building block time value of money equations, the keys on your financial calculator that you're going to be using more often than not. And I think we have the space here to draw a complete timeline. 1, 2, 3, 4, 5, 6. Perfect. 1, 2, 3, 4, 5, 6. Okay, here, college starts in a year. You may be wondering, why do the $30,000 payments have a positive no sign value when last time they had a negative sign? Well, it's because you're essentially borrowing here, in this situation, from your parents. And so we need to figure out the future value of the ordinary annuity. So we're going to put that in a rectangle around that value. And then we are going to determine the future value of an annuity due. And we're going to put a rectangle around that value. because we ultimately want to determine the future value as of the end of the 6th period. I want to make sure I got that right. The future value at the end of the 6th period. Yep, that's right. 6 years from now. So we actually have 3 operations here. So these 2 TVM wallets will get us most of the way there, and then we'll maybe utilize the space in the upper right-hand corner of this slide to get us where we need to go. So same storyline for the most part. This is an annual time span in between period markers, so only a true annual investment yield is going to work. We have 4 PMT payments in the amount of $30,000. 0 for a PV. Let's put an OA here in parentheses because we're first solving for the future value of an ordinary annuity. And for this value, it's ordinary for that value to be as of the timing of the last payment in the series. And when we calculate that, we get negative $128,345.73. So that's the first TVM wallet. Let's move down to the second TVM wallet. And again, I'm going to write in the variables in the building block time value of money equations, the keys on your financial calculator. And here we'll put an AD to remind us that we're solving for the future value of an annuity due. 4.5%. That true annual investment yield has not changed. And let's look at what we have here on the timeline. So we need to move from, for this example, for this intermediate step, we need to move from the future value of an ordinary annuity to this value, which is the future value of an annuity due. And we use compounding to do that. Remember, the action takes place below the timeline in the elbow of what I call the indifferent lines. And that action is this, times 1 plus I raised to the power of n, which in this case is 0.045 raised to the power of 1, because there's one compounding period. PMT payment, that's 0 because we've used compounding to determine the hypothetical lump sum. We can still use the PV register because it's reserved for a lump sum payment. Here we just have a hypothetical lump sum payment. And that hypothetical lump sum payment is $128,345.73. Now, before we solve for the future value of an annuity due, which is the second step in this situation, let's talk about what's happening here. Here we have what I call the switcheroo, because the value that we calculated in the first TVM wallet, we switch the sign now from a negative sign to a positive no sign value. We also switch the register that we're using. We calculated the future value of an ordinary annuity in the first TVM wallet, and now we're using the PV key, the present value key, as opposed to the future value key. Why? Because we need to move this value one period down the line below the timeline, as I like to think of it, because we can't add or subtract or compare monies in different points in time. That's TVM rule number 1. And so I don't think about money moving along the timeline, rather the action happening below the timeline. And so when we calculate the, I'm going to write this out again so we have a little more space. Future value of an annuity due. When we calculate the future value of an annuity due, we get $134,121.29. So we're almost there. I'm going to use this space up here rather than erasing, because you might want to review rather than having to go back and rewind. So let's draw the last TVM wallet. true annual investment yield is the same. Now we want to get from the end of the 5th period to the end of the 6th period. And we have this value here. We're going to switch it again. Why are we switching it? Well, because signs matter and it helps to call it what it is. This is going to be an investment or a payment that your friend is going to be making to pay back their parents for the money that was previously fronted. So the money will ultimately be leaving your friend's hands, and so there will be a negative sign associated with this future value. And so here we have 134, 121, 29, 0 for PMT payment. And let me run this math really quick. 4.5%, 1 for N, 134, 121, 29, 134, 129. And when we solve for the future value, in this case, we get negative $140,156.75. 140, 156, 75, and 75 cents. So let's double check our work. We need 2 equations to do this. We need, first, we're going to be using the building block future value of an annuity due equation. And then we're going to jump to the building block future value equation. So let's start with the future value of an annuity due, and here's that equation. One plus I raised to the power of uppercase N minus 1, and then in the denominator we have I, that's the true investment yield. 1 plus I, the true investment yield, in parentheses, that's our add-on expression. Future value of an annuity due equals, we know the payment. Thanks, Mom and Dad. 1.045. How many of those payments? 4. That's the relationship between uppercase N and PMT payment when you're dealing with an annuity. In the denominator, 0.045. And then out here for the add-on expression, we have 1.045. And when we solve for the future value of an annuity due, we get $121.29. Here's a squiggly line because we want to solve for future value now. So we use the building block future value equation. I know financial calculators, they do this, but we've worked with our financial calculator already, and we want to double check our work. It's good form to double check our work. So the present value in this case, and remember, this was the future value of an annuity due, but we got to do that switcheroo that we talked about, because now it is a present value the way that we think about it, because we want to determine the future value of this amount 1 year from now, or 1 period into the future, to be more exact and to relate it to this situation as of the end of the 6th period, 6 years from now. And so we are going to multiply this by 1.045 raised to the power of 1. And when we do that, we get future value equals $140,156.75. So we're going to circle that. That's the correct number, the number that we found in our 3rd TVM wallet. So that's a wrap. If you like what you learned in this lesson, please consider telling your friends about this channel, TVM Rules, and the book that made it possible. The book, Would Your Boomerang Return, flips the script on how the hard skill of the mathematics of finance is learned and taught. It fleshes out issues with terminology. It includes the first of its kind user manual for the mathematics of finance, and it presents an original 3-step systematic approach with an order of operations for applying the mathematics of finance to analyze and evaluate real-world time value of money situations. And speaking of mathematical order of operations, with a little bit of creativity, in the building block time value of money equations, you can see the birds in the braces, the hurdlers jumping over the brackets, and boomerangs in the parentheses. If you haven't purchased your copy yet, all the important information on this all-important topic is gift-wrapped within the cover of Would Your Boomerang Return? Until next time, enjoy the gift that is the present.